Welcome back to Confusing Residential Electricians for Generations to Come. Inevitably, someone will have to work on this, and they will be confused. So, sorry. Of course, the joke's on me, because that someone will probably be me in the future when I've forgotten how all this works. As you can see, I'm jumping straight in, got the back of my door labeled. I'm adding contact blocks to the back of the selector switch, because I need more contacts. I don't love doing that, but in this case it does make the most sense. Sometimes you can add a relay to get more contacts, but something has to power that relay, and I have 4 different power sources in this cabinet, but ideally I don't want to rely on any of those for this switch to work, so we're just going to use dry contacts. Here I am working on installing the cabinet light. EXM did send me over the door switch for this cabinet, and it's super easy because it just uses existing hardware to mount instead of having to drill any holes, so that is helpful. I am using LED tape light again, just like I did with the PLC cabinet, because I liked how that turned out. So I'm adding a whole nother power supply. Really, I could have used the power supply in the other cabinet and run wires over from it, but unfortunately I switched the 120 volt side, not the 24 volt side. So that means I would have to have both doors open for this door to work, which is just silly. So I'm just going to go ahead and add a whole separate one, and probably do the same stupid thing again. Of course, the one advantage to switching the 120 side is the power supply isn't always energized, so if it were to short out or something, it wouldn't show its ugly face until you actually open the door. These are just cheap Amazon power supplies, but I have a bunch of them in the house, and none of them have caught fire yet, so I'm going to keep using them. They are kind of big, and I should get ones with terminals instead of cords, but I'm stuck in my ways now. It also would have been nice if I had planned this out ahead of time and had studs welded in to mount the power supply, but I'm not that smart. I forgot about that part. So we had to drill holes. Not a big deal. It's going to be inside anyway. Here's our tape light. Strip that back so I can get to the wires. I don't use the connector that comes with it because I'm stubborn. Clean up our surface and get our tape stuck to the inside. I will be doing things pretty out of order in this video, so hopefully that doesn't trigger you. I mean, I'm going to be jumping from door wiring to lighting to piping back to wiring. It's going to be a little crazy, but that's just how it worked out. I could have edited it differently, but then I would be lying about the actual order of events, so you get the truth.
I need the truth.
And on that note, here I am jumping to grounding. I am grounding from my main ground bar to the stud on the side of the cabinet that will bond the back plate to the enclosure, and then from that to the door. So everything should be bonded together. I don't actually know how to size the wire going to the door. EXM gave me a 10 gauge wire, and then I ended up using a different one because I messed up the first one, but it all stayed 10 gauge. I don't know if that's actually right, but should be fine. All the power sources on the door are fused at like 4 amps, so it should definitely trip the breaker if something shorts out. Not that it's going to. I did the door grounds first so they wouldn't be in the way when I started running my conduit from the panel to the door, and I am doing the same thing I did on the PLC panel with the flexible conduit. I did like doing that. It was my first time doing that, but it worked out well. And thankfully, I got all these studs welded in the right place because that would have been embarrassing. But they all fit perfectly, so can't complain about that. I did mess up and make the conduit a little too short the first time. It was a little tight when I opened the door all the way, and it was pulling it closed pretty hard. So I made it a little longer. It wasn't a big deal. I had enough left over, thankfully. Now that that's finished, it's time to trigger everyone and get some stickies on here. I did clean my surface for the best chance of them staying stuck. Also, because I have the conduit, all the pressure is on those straps when opening and closing the door, so I'm really not too worried about the stickies falling off. They are inside, like I said, pretty much perfect conditions. They'll probably still fall off, but I'm not going to tell you. I'll never admit it. At this point, I started wiring the door. It actually wasn't super simple. This is one of the more complicated doors I've done in my limited experience, just because of how many different power sources there are. Usually, you jump one hot up to the door, one neutral, and you jump all the lights out with that power source. But in this case, it wasn't quite that simple. So I had to take it slow, make sure I did things right, redo a couple things. It all worked out, but definitely wasn't super easy. It was also designed by an idiot, so what can you really expect? I didn't make it too far with the door because I didn't have any orange wire at the time. So, as I said, things are going to jump around. I'm going to move on to some piping till I get that orange wire. I have these two 2-inch EMTs coming over from the old system, and I need to reconnect them. The one on the bottom is going to be the generator backfeed to my main panel, and the one on top will be the feed to my ATS as the essential source. Since I am acting as every contractor, I'm going to line up my pipes with the actual device that they're going to feed That way the wiring comes out a little cleaner. Went ahead and got all my measurements for that. I definitely had to get front to back right so these pipes would line up because they don't bend too easily. Drilled my pilot hole, drilled my half-inch hole so my knockout arbor would fit in there. And then I went ahead and punched out my 2-inch holes. I'm still rocking the old crank slug buster because I do not have a hydraulic knockout punch. Those things are not cheap, but it's all good. You got to actually do work every now and then. If you're in the market for a knockout punch set, I recommend getting one that splits the offcut in half. It makes it a lot easier to get out of the die or the cup or whatever you want to call it. The old school ones would just make one piece, and you would spend a lot of time trying to get them to come out, but I think all the new ones are like this now. Now that I got my holes punched, I can go ahead and line up my conduit bodies, or conduits. These are LLs. If you don't know how to tell, just hold it like a pistol. If the cover is on the left, it's an LL. If it's on the right, it's an LR. If it's on the back, it's an LB. If it looks like a T, it's a T. If it goes straight through, it's a C. And if it has 4 openings, it's an X. So good luck. There will be a test later. Now that I got my measurements, I'm going to go ahead and remove the pipes, which have not been removed since the house was built, because I can't really cut them in place. I probably could if I really wanted to hack at it with a sawzall, but I'm going to use a bandsaw, so I'm just going to take them out, try to do it right. These conduits are also oversized. They really don't need to be 2-inch for the size of circuit we're running through them, but because I did 2-inch in the first place, I don't feel like using reducing washers. I think it would look like crap, so we're sticking with 2-inch. That way it's nice and roomy. I'm using rigid nipples to go up into the cabinet because I don't have enough room to actually run pipe and connectors between the conduit and the cabinet. And after tightening the lock nuts way too much and trying to get this thing to raise up, it was still not level, so I threw a smaller nipple in. And we got it level so we can strap it down. Here is me cutting my second pipe with my bandsaw. It is one straight cut, if I do say so myself. One person commented and said, "I can't believe you're wearing shoes and no socks." Sir, how dare you? I am wearing socks. I'm just wearing ankle socks. I was born in the 90s, so that's what we do. I would never wear shoes with no socks. That is disgusting. All right, what was I talking about? Oh yeah, deburr your pipes and all that good stuff. Make sure you don't have any sharp edges. Here's my second pipe going in, and I am using pipe and connectors here because I have room, barely. But they didn't quite line up because I am not very good at my job. So I ended up having to take it off and trim just a little bit off, which tested my pipe cutting skills again. That's all we needed, just that little bit. If it was already too short, I probably could have cheated it in the coupling, which of course I would never do. But when it's too long, you're kind of screwed, so you got to get it right. Thankfully, I didn't actually have to buy any 2-inch hardware or pipe because all of this was left over from the old ATS. I actually still have some 90s and things laying around. Bet you didn't know I was so environmentally friendly. Now we're just going to tighten all our set screws, all our lock nuts, so we have that effective ground fault path. Even though we're going to be running equipment grounding conductors, got our bushings. We don't need grounding bushings because this is only 240 volts. But there's our pipes all lined up, ready to go. Should be nice and clean when we run our wires. But speaking of wire, we got our orange wire back, so let's jump back to the door. I know I've talked about it in the past, but there's a lot of different ways to do doors. Some people square off all their wires, some people round the wires, some people don't use stickies, some people use Conduit. There's a ton of different ways, but I decided to round off my wires this time. I started at the top, started at the furthest point, worked my way back, tried not to forget any jumpers. I did forget some, to be honest, but overall, it turned out pretty good. It could always be better, but it turned out good. If anyone is wondering what all these pretty colors mean, I can explain it to you. Don't expect it to make sense, but this is the standard I have created. Black and red is 120 volt. Blue is a redundant 120 volt that is backed up by UPS power. Purple is 24 volt from my PLC cabinet. That's 24 volt DC. White is 120 volt neutral. And orange is going to be my generator control power, which is probably going to be 12 or 24 volts from the actual generator batteries. So don't say I didn't tell you, future person who's working on my house. Now that the door is pretty well finished, I'm going to jump into some of the power wiring. I will be using all copper THHN or THWN. The 175 amp primary feed to the ATS will be 2-aught, and the generator backfeed and generator power will be 1-aught because that is only 150 amps. The ground will be number 6 because it's just equipment grounding conductor, and that will work for both circuits. Normally when you're pulling wire through pipes, you're going to make up a head for your wires and you're going to use string or rope to pull your wires through. But on short runs like this, sometimes it's easier to just push one wire at a time. And since the wire is a pretty good size, you can actually push it pretty far before you need to pull something. I don't know if any of you have checked the price of wire recently, but it's insane. Makes me regret using copper in this house, but I'm not going back now. There's really nothing wrong with aluminum when it's a larger size like this, but I started with copper and I'm not going back. I'm definitely going to regret that decision when I buy the wire for the generator itself, because that's going to be well over 100 feet of 1/0. But, you know, it is what it is. I also prefer getting color-coded wire. I know that also costs a little bit more, but it is nice when you're tracing circuits out, looking through conduit bodies, conduits, whatever, and you can see what color the wire is and you don't have to re-ID everything with tape. It's just, you know, just me being privileged. So if you're following along at home, which you definitely should not be, never repeat anything I do in these videos, just use aluminum. It's going to be a lot cheaper, and it's really not going to matter in the long run. All right, there's all our power wires pulled. I got plenty of slack in the MDP. I am calling it an MDP, by the way, main distribution panel. Even though it's not the main principal, I've decided it is the MDP. Going to go ahead and start hooking up our grounds. Like I said, this is number 6. I think that's good up to a 200 amp circuit for the equipment grounding conductor. And I'm landing them on my ground bar, which thankfully does have a few large lugs. It actually has just enough large lugs to land all the large grounds. There will be 4 of those grounds coming into this ATS, one coming from the MDP with the essential circuit, one going back to the MDP with the generator backfeed, one coming from the generator itself, which will not be landed now because I don't have a generator yet, and the last one going out with the load of the ATS, which goes just to the right into that lighting panel. Now, one issue I did notice after it was already too late is that I have 2 different paths for the neutral current to flow back to my main distribution panel. Now, I have one neutral coming in from the panel, and one was meant to be the return when the generator was being backfed into that main panel. But long story short, there's 2 neutral wires going to the MDP, and they hook to the same spot, essentially. So the unbalanced load will be taking 2 different paths back to the MDP through 2 different conduits, even though only one set of hot wires will be energized. So that's not ideal. Now, the neutral current is pretty minimal most of the time. I don't think I'm going to have an issue with heating, but I am going to keep track of that. The only way I could have solved it really is to have a 3-pole transfer switch and kind of rework where the neutrals all went. But like I said, I'm going to keep track of it. Hopefully it won't be an issue. Here we have our backfeed wires landed, and you can see that they are pregnant. So there is an issue here I need to solve. The problem is this little bus bar in this distribution block has the stud too far forward. When you put the lug normally on the stud, it's fine. But when you stack lugs and try to put them on, the lug is too far back from the edge of the bus. Now, I thought maybe I could use a different brand of lug, but the Burndy lugs do the same thing. Ilsco and Burndy seem to have the same spacing. So I don't think getting new lugs is going to solve the problem. I could also cut the bus bar, but I really don't want to modify it like that. So the solution I came up with is I need to create a spacer that will go on underneath the lug so that it can finally sit flat. I guess it's time to dig through this bin of bus bars and find some material. I'm pretty sure this is all tin-coated copper, but I want to be sure there isn't any steel in here. Let me go grab a magnet. And that brings me to the sponsor of today's video. That's right. Someone's crazy enough to sponsor my craziness. And that someone is Traction. They sent me this smart track sensor to play with, and here I am already misusing it. It does have a hell of a magnet though, but that's just one of its many features. Once this thing's attached to a piece of equipment via a threaded connection or adhesive, that's what the magnet's for, to assist with the adhesive, it'll start monitoring vibration, temperature, runtime, RPM, even audio. And it's all transmitted wirelessly to its own receiver on its own network, so you don't have to worry about interfering with existing systems. Traction then takes that data and uses the help of AI to compare your asset to all other similar assets within the industry. It allows you to take preventative maintenance to the next level. And that's just one of many services Traction can provide, so if you're interested, the link is in the description below. Also, apparently the receiver can be a disco ball, so that's pretty cool. All right, back to making our spacers now that we've picked out a pretty little piece of bus bar. It actually already has holes in it, which is convenient. I think this came out of a VFD. All I gotta do is split it up, just like that. So easy. As you can see, the inside is in fact copper, even though the outside's shiny and silver. I just hacked it up with the bandsaw, smoothed it out with some files. It's plenty thick enough. It actually could have been a little thinner, but can't complain. This is a copper on copper connection, so I feel good about it, and it accomplishes what we were trying to do. Obviously, probably not recommended by the manufacturer, but it did the job, and now my wires are nice and straight and sitting pretty, so I'm happy with it. I will also be using this method on that lug because there's going to be 2 neutrals, but the others are singles, so I don't have to worry about it. I'm also using this copper shield on pretty much all my connections. I'm not stuffing the lugs with it because it makes a big mess, and the lug manufacturers say it's optional. If it was a really corrosive environment, I think I would try doing that from this point on. But in terms of the connections themselves, I've tried to make it a standard to goop them all up with this stuff, just in case it ever helps in the future. Here I am landing all the conductors into the normal side of my ATS. This is coming from my main distribution panel, and I did decide to get fancy even with the wires that did not have crimp lugs. I am using printed labels and heat shrink just to hold the label on. Clear heat shrink and labels makes everything look nice, so it's another thing I'm trying to add to the standard, is to always do that when possible. It takes a lot of time, but this is at my house, so I can take as much time as I want. You can't stop me. Also got my wires done from my generator breaker down to my distribution block. That's really not going to matter right now, but just got it done ahead of time. Here I'm pushing my wires in from my essential panel, which is going to go to the load side of my ATS. I was struggling a little bit there, but we got it. Short run, just scraps of wire, basically. I swear it's always the smallest runs that give you the most trouble. It's the time that you think, no, I don't need a fish tape, or no, I don't need a string, it'll just push. Those are the times when it never works and fights you the entire way. So you just got to learn and actually use the proper tools for the job. But, I'm not going to. I'm not going to learn. I'm going to be stubborn. So there we have the load side of our ATS landed, which jumps right over to that panel. Now all that's left is the emergency side of the ATS, which will jump over to our distribution block, which jumps up to our generator breaker, which also jumps back to our main distribution panel. And if all that seems confusing, it's because it is. It was confusing me half of the time. But as silly as my design was, I am grateful that I made the enclosure as big as I did. It seemed kind of large when it arrived, but landing these power wires was honestly a breeze. There was plenty of room to make it look good. Now that those big boys are all finished up in the ATS, it's time to finish up the control wiring. I need to run the wires to the actual ATS itself, the switch itself. I did hold off on this last time because I didn't want them to be in the way when I was running larger wires. I think it would have been fine, but it makes it a lot easier when you can actually see the final placement of all the large power conductors and then just route your small conductors around them, because it's a lot easier to do that than vice versa. Of course, normally the panel shop just builds the panel and the electrician just has to work around whatever they do. But because I'm doing everything, I can take advantage and actually do it in a way that makes sense. So before I wire the coils themselves on the ATS, which is those terminals on top, there's also another set on the bottom, I want to verify what they actually do. I'm pretty sure the top energizes to go to normal position and the bottom energizes to go to emergency, but I'm not 100% sure. I do have a panel right next door, though, and I got this 40 amp breaker with 16 gauge wire. I mean, what could possibly go wrong? So I'm just going to hook it up and verify that it does in fact do what I think it does. Now, I'm not using a 40 amp breaker to purposefully be dangerous. It's just the smallest 2-pole breaker I happen to have. And I'm only turning it on for a split second, so it's fine. Probably. All right, well, it did what I thought it would, but let's move it to the top and make sure that works as well. I am not just testing what the terminals do. I'm also testing to make sure the actual switch works, because never really verified that. All right, well, that's good news. I can finish hooking up the control wiring. Now, in terms of the wires that hook directly to the power terminals, they're basically unfused. I mean, they're on 150 amp fuses, but that's basically unfused when the wire's this small. I tried to keep them as short as possible, and I also ran them separate from the regular control wiring, just in case something ever does happen. But it's only about 18 inches of wire, and it goes directly to a 4 amp breaker, so it would have to short out between that main lug and the breaker. There's really nothing there to short out, so hopefully it won't be an issue. All right, that's the control wiring done. You know what that means. Close your eyes if you get motion sickness. It's time for zip tie cam. And boy, were there a lot of zip ties to cut. I'm using my flush cutters, so don't yell at me. So when you feel around in this cabinet, you won't get cut by a zip tie. You will get shocked, but you won't get cut by a zip tie. I might just start a whole separate channel about cutting zip ties. It's going to be nauseating. Anyway, speaking of nauseating, if you did close your eyes, it's over. I promise. You can open your eyes again.
It's over now.
Alright, let's jump to another task in this messed up timeline. This is actually heat shrink for bus bars. I just wanted something with some sort of insulative value to shove in these conduits. This is not required. No electrician does this except me in my own house. But I don't like how the wires sit on those edges. They are rounded, but it really pushes into the wire pretty hard. So I did that on both my conduits just because I can. Would it be an issue? No, but I did it anyway. So, there you go. Full transparency. All right, well, the transfer switch is pretty well buttoned up, but we still got this mess to solve. So let's get to it. Gotta land all these wires. If anyone's wondering where the insulating shield went that covers the main lugs on this panel, I got rid of it. It was getting in my way and it annoyed me, and now it is gone. Well, that turned out pretty good. I did end up rerunning the ground from this panel on the left because the old ground was too short when I rerouted everything. I did reroute the grounds when I did all this because I had to redo most of them. Ignore that cut ground over there. We'll get to that in the next episode. But overall, looking pretty good. There's my feed to my ATS, the normal side, coming up to that 175 amp breaker. Employed my new labeling technique. Same with the neutrals. You can see the old versus the new. And then there's our generator backfeed wires coming up, which currently aren't hooked to anything because I'm still using that breaker as a temporary. Once I'm ready to shut most of the house down, I will transfer those wires over, and I will also get rid of all these temporary wires that I ran in the last episode, or the first episode, I don't even remember, and this panel will look a whole lot better. Now that all my large wires are pretty well landed, or at least as many as I can do right now, I'm going to go ahead and torque all my connections, that way I can start turning things on. I do have all the torque specs for each device. I even printed some of them out in labels to make things easier. So I just got to go through and make sure everything's nice and tight. I did have to remove these bottom wires for the emergency feed to get to the load wires of the ATS. I should have thought of that ahead of time, but it really wasn't a big deal. Just move them out of the way and put them right on back. I did leave the load wires feeding that panel off because that panel is still hot, so those lugs are still hot on the bottom. I don't want to hook those up until I do my little shutdown, but they are ready to go. I did use this torque seal on all of my connections, just in case someone breaks into my house and starts messing with my bolts. But it's just another thing. It's just one of those other things I'm adding to my standard. I'm trying to make things better every time I do a new project. So from now on, I'm using torque seal to verify that I torqued things. Finishing up with the ATS, we're going to go ahead and cut our Conduit covers. This is always satisfying to finally close things up and make things neat. Always deburr your plastic so no one gets their little handsies hurt. And then just throw them in there to hide all your crappy Conduit wiring. So ultimately what I need to do is shut that breaker down, which is my temporary breaker, hook those wires up, remove my temporary breaker on that side, and that will free up that breaker for me to hook up my generator backfeed. But before I do that, I want to energize this breaker, which is the normal feed to the transfer switch, and that will also give me control power so I can start testing the transfer switch before it's hooked up to that panel. Because when it's hooked up to the panel, I'll be transferring the whole load of that panel. But right now there's no load, so it's a good time to test it out without interrupting anything in the house. But first things first, anytime you add new circuitry, you should test to make sure nothing is shorted out, phase to phase, or phase to ground, or phase to neutral. We don't want anything to blow up unexpectedly. I prefer my explosions to be planned so I can bring my shrapnel umbrella. Another thing I'm going to do before I turn this thing on is I'm going to jump the normal and emergency side of the transfer switch, because right now I have no emergency power available, and I want to be able to test everything. So I'm just going to jump these out and fool the transfer switch into thinking it has both sources. The last thing I need to do is configure all these phase monitors because they're all still at default settings. I need to set the undervoltage, the overvoltage, and the time delay. I'm not really going to do a time delay on these because the PLC will handle all the timing, but I do need to set undervoltage and overvoltage. I set them to about 10% high and 10% low, which is a bit extreme, but most of the time we're going to have a full outage when this generator kicks on. Plus, I can always adjust them in the future. They are easy to change and easy to adjust. They're not very accurate though, so that kind of sucks. All right, let's quit messing around and give this thing some power. Nothing blew up immediately, so that's good. I'm going to put my selector switches to manual, and turn on my control power. We have light. We only actually have light because I jumped it out to one of the sources. I don't have my PLC redundant power coming over here yet, but I wanted to see how the lights looked, and they look good. So that is good news. I'm not changing them now. As you can see, we have red lights on 4 of our phase monitors. Turn the light off so you can see that better. Red is actually good. Red means the voltage is good. The top 2 are off because I do not have my utility power over here yet. That is another project. But so far, so good. And of course, I spoke too soon because as soon as I closed the door, I realized we are showing emergency position and we are in normal position. So that is an issue. See if our lights work. Well, at least the push to test works. That is a plus. Did I get you? I bet I got you. The utility available light is not going to work until we are on that circuit, like I said. Even though the states are wrong, let's see if it transfers. Look at that. It is changing. Well, at least the switch works. We just have our indicators wrong. So let's fix that, shall we? Luckily, it's an easy fix. I just picked the wrong set of contacts on the transfer switch. I actually thought I tested this, but clearly I did not test it correctly. So, whatever. Easy fix. Can't complain about that one. Now our state is correct. Don't touch those wires, by the way. I'm sending power to them, but it's fine. Just don't go near them. Now it appears our indicator lights are accurate, so that's good news. Transfer is still working, so that's all good news. Now let's flip it to auto and see if it works. It does not, and that's actually good news because it shouldn't. The PLC should control an auto, not the push buttons. There's our little reversing contactor. As I press the buttons, it's just a little quick flick of the indicator. You can barely even tell. And here's inside the transfer switch, if anyone was wondering. We can add that to the list of things I would not be doing if this was under load. But last thing I want to do, put it back in auto and jump out the PLC contacts to make sure they actually work properly. Alright, that all seems to be working, so I'm pretty much done testing for now. There's a few statuses and PLC inputs and stuff that I didn't really test, but that's all stuff that's easy to change in the future, even with the switch in operation. So for now, we're going to pull out these silly jumpers, making my cabinet look like crap, and get ready to turn this thing on for real. But the first step will actually be turning it back off because I don't want that energized while I'm working on everything else. Then we can get ready to hook up these generator wires hanging in the breeze. Luckily, that didn't shock me. Let's turn the whole house off now. Really mess things up. Disconnect our temporary breaker, which has been working beautifully for a few months now. Could have left it like that forever. Disconnect the ground, disconnect the neutral. Everything is off at this point, so you don't have to worry about me killing myself, at least for now. Open up these lugs. I had these wires ready to go. I had them pre-labeled, pre-cut, pre-gooped up, which means they weren't perfect when I put them in. They could have been a little neater, but I'm fine with it. At least it made it quick and made the downtime as short as possible. I will live with them not being perfect, I guess. Gonna torque them down like everything else. Mark them like everything else. I hate these lugs on these sub panels. They are so flimsy, but I'm just gonna have to ignore that because I can't do anything about it. Turn my essential feed back on, my normal feed. And the switch is still in the emergency position at this point, so we'll go ahead and transfer it. Boom, we have light. That panel is now being powered by the transfer switch instead of my temporary breaker. So that is good news. And we can finally pull these messy wires out, which, bothered some people. And I can also yank them out of my MDP because they were making my main distribution panel look terrible. So this will be much better. Go ahead and hook up our generator backfeed wires. Just like that, like magic. That's looking nice and clean. Pretty happy with how the MDP turned out. I am going to rework these main feeds in another video because I don't like them. But overall, I think it's looking pretty neat. Could be better, but pretty neat. Same with the essential panel. Looking pretty good. I can finally close that up after months of being open. No one has to get shocked anymore. And there we go. Let's see what we're drawing on this puppy. 18 amps and 9 amps. So barely anything on this 200 amp switch, 175 amp circuit. But at least I finally get to push some current through this thing. So that's it. Transfer switch is physically done. There is a little bit left to do in the future. I'm pretty happy with how the door turned out. Could be better. I know everyone gives me crap. Oh, he's saying it looks bad to get sympathy. No, there are people who make things look absolutely perfect. And I've met these people. I've seen these people. What I do is not absolutely perfect, but I'm happy with it. It's good enough for me. And overall, I think the Switch turned out good, especially for a residential transfer switch. My God. Close her on up. Here's the front. Hasn't really changed. That generator breaker still has a real nice fit. Transfer switch, still a nice fit. But that's the transfer switch done, at least until the generator is actually installed. Then we'll run a few more wires to it, do a little bit more testing. But that's it for now. Thanks again to Traction for sponsoring this video. Check them out in the description. They got some cool stuff. Next time we'll do some things with the main breaker and some Kirk keys, get those interlocks installed. See ya.